Thank you very much, Martin. Good afternoon, everyone. So I'm Rhys Davies. I'm based at Wizard at Cardiff University. Thank you very much for inviting me to talk at this afternoon's workshop. I have a mission of guilt when we start this. I don't do small area estimation, so please be gentle with me. You won't see anything like we saw this morning. There'll be lots of small area statistics, though, which I hope you find enlightening and enjoyable, and hope it will kind of trigger some debate anyway, if nothing else. So thank you very much for listening to this afternoon. So, trade union membership. It's widely accepted that good quality work is important for productivity, yes? So the ability to go to work and to learn new things, to have autonomy over what you do and how you do it, to not work intensively or to be overstretched like that, the ability to get promoted, the ability to feel valued at work, these are all important things for productivity. And one of the important aspects of job quality is employee voice, the ability for workers to kind of represent their interests at the workplace. And of course, trade unions are important. One important mechanism is a vehicle for providing employees at the workplace with voice. The empirical literature on union membership demonstrates that unions are certainly good for employees. And the empirical studies that we used to get 20, 30 years ago, which suggested that they might have had a detrimental impact upon establishment level performance, they tend to have subsided now. They don't tend to have, we don't demonstrate that they have a bad effect on workplace or employer performance. However, there's a downward trend in union membership. Union membership peaked in about 1979 at over 13 million. It's currently just over 6 million. Statistics are produced once a year from the Business, Energy and Industrial Strategy. The main source of data on union membership is the Labour Force Survey, and that was started collecting union membership information about 1995. And we're currently down to 23% of employees indicating that they are members of trade unions. But there is regional variance, there is spatial variance of union membership. It varies from 17% in the southeast up to about 28% across northern England. In places like Wales, it's even higher, it's 31%. Northern Ireland is actually higher than Wales, usually about 33, 34, 35%. And it's always been the case that we have these large spatial variation in union membership. They cannot be explained by the composition of employment in these places. They cannot be explained by the composition of occupations, industry, or the people who work in these places. And that's been the case now for many years. So even the earliest econometric studies of union membership always found significant spatial effects beyond that which could be explained by industry, occupational effects, and so on. So why is this the case? Why do these spatial variations in union membership persist? And those in the industrial relations area point to the importance of traditions, customs, and cultures that emerge in particular localities due to the prevalence of certain types of history of employment in those areas. And Beaumont and Harris, 1988, they suggest that all the statistics like trade union membership produced by Bayes, they always produce statistics by broad standard geographical areas, government office region, but that really doesn't help us understand trade union membership. These kind of things are much more need to be examined at a much more fine-grained local level. So that's what we're doing in this presentation. So we know that trade union membership is high in some places because favourable attitudes towards unions exist in particular places. How has this been empirically demonstrated before? Well, an American economist, Thomas Holmes, did a fantastic paper on this in 2006, where he created a data set of union membership within kind of care homes and grocery stores across the US. And he was able to demonstrate that union membership in care homes and grocery stores in West Virginia and Pennsylvania were higher than other places. And that was linked to the location of the old coal and steel sectors in those areas. So the idea that union membership spills over through time from the past, but also spills over from once highly unionized sectors into very non-unionized sectors. So you get spillover effects in different directions. What are the mechanisms for this? Economists point to the importance of experience goods as an explanation of union membership. Experience good is something where the benefits to purchasing that good are not easy to understand. You might not understand what unions might do for you. You might not understand or be able to perceive the why you would need to join a union, or when you might be in trouble and need the support of a union. So the experience good tells us that union membership is often recommended by close associates, families, friends, colleagues. They'll tell you on your arrival at a workplace, you should join the union. Yeah, why am I joining the union? Don't ask, just do it. They're good. You should do this. Family are particularly important in this respect, and there has been empirical research on the importance of family and trade union membership. My own paper with Alex Bryson and also Blandon and Mach in 2003 demonstrate that the children of unionised parents like to be members themselves. This is particularly apparent when both parents are members and when parents are active in trade unions. These effects are stronger in areas of high union density as well, so where there's lots of trade union membership. There's also gender effects. Daughters pay more attention to their parents than sons do. And in fact, when it comes to union membership, daughters pay more attention to their mums and sons pay more attention to their fathers. And these are patterns that we also see in kind of the political science literature where they study voting behaviour and voting patterns. So this is a mixed methods project. We go out and talk to people also, and this is the kind of stuff we've been talking to trade union activists in South Wales, why they join unions, and you get these things. I've always been a member of union. It was just natural. It was just something we always did. And then the bottom quote there is of someone who was brought up in a household that was where they were trade union activists, and they were being part of the part of the conversation that they would hear their parents having when they were supporting the organisation of the local branch of the union. So that was the kind of highlighting the importance of family. So what have we been doing? Given the importance of locality, we've produced some small area estimates of trade union membership. So there's a special component to this talk, honest. We've taken the quarterly labour force survey for about 22 years, which is, you can say, the official source of data on trade union membership. We've merged all those quarters together, and we've produced small area estimates of union membership for approximately 405, 406 local authority districts. There's a variable in the labour force survey, UALAD, which is the local authority district structure before the reorganisation of local government in the early 2000s, and it persists in the labour force survey throughout. So these local authority districts aren't quite the ones that we have today, but it's forever present in the labour force survey, so you can produce consistent estimates of these trade union membership statistics for these areas. So we've pulled data over many years. We've also introduced some data from the annual survey for hours and earnings, which also asks information from employers about whether employees' earnings are covered in collective pay agreements. So you've got the employee perspective from the labour force survey, and then you've got the employer perspective on collective agreements from the annual survey of hours and earnings. And interestingly, sometimes those two sets of results don't agree with each other. We have examples of where many employees from large organisations in the labour force survey are telling us, for example, yeah, my pay is set with respect to a collective agreement. And then from the annual survey of hours and earnings, you do have instances where you can see the organisations where these people are working, and they say, no, the person responding to the ASH has said, no, these people don't have their earnings covered by collective pay agreement. So you do have instances of that. Of course, both for surveys, and they're both prone to errors, of course. So all this data, by the way, is also available on a funky webpage called Union Maps, which we have on the Wizard website. So you can go to the Wizard, look at Union Maps, and all of this data on the small areas. You can produce local area reports, and you can produce maps of the UK for trade union membership. So I put in the Institute for Fiscal Studies, and I was relieved to see on the way in here this morning that we are actually in Camden. That was a relief. That would be embarrassing if we weren't. So Union Maps, what do Union Maps tell us about Camden? Union membership in Camden is 17.9% over the last 2 decades. You're ranked 372nd out of 405, so come on Camden, do better. We've got estimates for union presence and union coverage also, and their ranked positions. We've also produced a propensity, which is derived from a regression model of union membership where we control for age, some personal characteristics, occupation, industry, sector, and that's simply the coefficient on the area dummy variables, and it's the rank of that. So after controlling for other factors, Camden is ranking 319th in terms of its levels of trade union membership. So all this data are freely available to you. So it's great. So you can also on the website, we can see there's obviously been downward trends in trade union membership. So over time, we can see the red areas represent high levels of union density, the blue areas low levels of union density, and we see gradually over time the country is becoming increasingly bluer. So we have lower levels of trade union membership over time. We can also compare levels of union density in the first decade, so 2000 to 2011, with subsequent changes in union density which take place across areas. And we highlight the complexity of the patterns that are occurring in terms of changes in union membership in the UK. The northeast, that's traditionally high levels of union membership. Those are the red dots on the bottom right-hand side there. So areas of traditionally high membership. Union membership in the northeast is free falling. It was about 40% back in 2000. It's now about 29%. A lot of areas in the northeast are experiencing declines in their levels of trade union membership. Wales, I've got to talk about Wales, obviously. More of a mixed picture. The union membership is declining slightly in the South Wales valleys, but not to the extent that it is in the northeast of England. And that's perplexing for us because we kind of regard those areas as being quite comparable: mining background, industrial background. Union membership in Wales overall is relatively stable, and that's the data tells us this has been driven by increases in membership within kind of more rural areas of Wales, so across North Wales, in Denbighshire and Conway, also in West Wales, Ceredigion, Carmarthenshire. We have levels of union membership in those areas is holding up quite nicely. South Downs, an interesting area. There's a strip of local authorities across the south coast going from Hampshire all the way to Brighton, where union membership is either stable or increasing. Don't know why that is, and that'd be something that we have to investigate that, probably more kind of in-depth qualitative research to understand what's going on across the south coast of England there. A whole strip of local authorities across the south coast where union membership seems to be holding up. The chart also shows that union membership is not declining everywhere, of course. So yes, we have about 405 areas. There are about 50 areas where union membership has even remained stable or is going up over the last 20 years. So it's not going down everywhere, clearly. Right, where is the most unionised part of the country? It's in Cumbria. That's the north of, for those who don't know the northeast geography. So we're on our way now north of Liverpool, heading towards Scotland on the left-hand side of the country. We're in the northeast, and these are, I would say, this is the kind of the most unionised place in the UK. We'll start off at the top, which is a place called Allerdale, on the orange shading there. This used to be the location of the Cumbrian coalfield. So that second map in from the left-hand side there, those red dots represent the locations of old coal mines in Cumbria. So clearly you see the importance of the industrial heritage in Cumbria spilling over into the current day. This was a coal mining area. The mines in Cumbria, they're on the coast and they go out underneath the ocean for miles and miles and miles. Who want to work there? Copeland, the most unionised place in the UK. Union membership of 54%. If you want to improve union membership in your locality, you cannot do better than getting yourself one of these, a nuclear processing facility. Guaranteed to increase trade union density in your locality. They provide stable employment, because they're not going anywhere in a hurry due to the muck that they create in the ground. They create stable employment for a highly unionised, well-paid workforce. And unlike the nuclear waste, we hope, the trade union membership spills over into the local communities. The families, the friends of people who have worked at this site for now generations are influenced by the union joining behaviour at this site. So even in occupations and industries in that locality that have nothing to do with that plant, union membership is higher in those occupations and industries than we typically see for them. Barrow Furnace, that's at the bottom of the map there. That's the kind of the third. So you've got Copeland's the most unionised place in the country. Barrow is the third most unionised place in the country. You mentioned about 45%. And Barrow, of course, has a long history of shipbuilding and steel. And it also is responsible for the construction of UK's nuclear deterrent with BAE Systems manufacturing these nuclear submarines. So clearly nuclear is important. So an interesting little snippet here. These constituencies, Copeland, Barrow, and Allerdale's covered by Workington, the constituency of Workington. The most unionised part of the UK, it's all Conservative, because these unionised workers, highly paid unionised workers, they never warmed to Jeremy Corbyn very much, because he had a very strong anti-nuclear stance. So you have this perplexing thing where they're highly unionised, union membership levels off the scale, but they are currently at least, they are 3 Conservative constituencies. Interesting. Well, that's the point. You have to understand the specifics of the area to really understand union membership. That's what all this is about. So the importance of coal mining. So that's kind of union maps, and that data is there for you to look at. Please do. So it's been long understood that coal mining areas are once dominated by coal mining are important places in terms of the persistence of trade union membership. And that photograph there is the Durham Miners' Gala, which was first established in 1871, and people from the pit villages of Durham and the surrounding areas congregate in Durham town centre once a year and march behind these beautiful banners that represent the local lodges of the mining union. Brass bands are playing and all sorts. So it's kind of an expression of working class solidarity and comradeship that takes place once a year. Even though the last mine in the Durham area closed down in 1992, these people are still parading down Durham city centre behind these barriers. Michael Gove made a little mistake at the last election. When Boris Johnson was about to do his victory speech, Michael Gove was the warm-up act for Boris that night. And the Conservatives have taken a seat in North Durham. And Michael Gove said, just imagine this. Next year, the Durham Miners' Gala will be taking place in a constituency that is held by the Conservatives. Now, thankfully, Michael's grasp of electoral geography wasn't great. And whilst North Durham did go from Labour to Conservative, Durham Central did remain a Labour constituency. So the Durham Miners' Gala is still taking place in a Labour constituency. But of course, if he had interrogated union maps, he would have seen that the Conservatives already held the three most unionised parts of the UK. So what can we do? What can we do in terms of examining the impact of coal fields and coal mining areas on the persistence of union membership? Well, we're going to see if we can demonstrate whether these places still have a separate and additional impact upon the likelihood of being a trade union member. Can we see spillover to neighbouring areas, and does this affect the area across Britain? How are we going to do this? So sorry, a potted history of coal mining. Coal mining, always a very small but important part of the UK economy. Employment in coal mining peaked about 1920 at just over 1 million, about 1.2 million workers. The employment share peaked about 1924 as at 6%. Highly unionised sector, about 80% of these people were members of trade unions. So a highly unionised sector, which most importantly dominated localities in which it was based. This is data from the 1921 census. So yes, across the industrial areas of South Wales, we have 35% of that area was engaged in coal mining. But then you get into particular places and you can see that mining dominated employment in these areas. So under this line, which is where I came from this morning to D here, 74% of male workers aged 12 and over were engaged in the coal mining sector. So these places dominated these localities, and as I said previously, they had levels of union density of 80% plus. So obviously there's a strong history of union membership in these areas. So how can we identify the coal field effect on union membership? So the wonderful Tina Beattie, who's based at Sheffield Hallam University, she does lots of work on coal fields. She's been responsible for producing lots of data to various coal mining, coal field task force. What are we going to do about the deprived conditions in these areas? So she has developed definitions of coal fields based on the 1981 census. And roughly speaking, it's where 10% or more of male residents in an area were working in the coal sector. So 1981, the mining sector had already declined. This is kind of a snapshot of the final kind of years of the mining sector in this country. There was another wave of pit closures after 1981, which led to the miners' strike in 1984, and eventually the industry disappeared. So we have this snapshot picture of what coal mining looked like in the UK in 1981. So we've got our definitions of coal fields, which are the hatched areas on the map that you can see there. Obviously coalfield in South Wales, and you see South Yorkshire there, but also small coalfields as well. The Kent coalfield was a very kind of important, in the context of the miners' strike, a very militant coalfield in the 1980s. So and also in Gloucestershire there was a small coalfield as well. So those are our coalfields, the 18 coalfields that we have. We also want to look at geographical spillover. So what's it like, what's the effect of being near a coalfield on your likelihood of being a union member? So we can look at this by deriving distance from the coalfield boundaries. So the coalfields are defined in terms of LSOAs, or data zones, in Scotland. And so for all of the LSOAs and data zones across the UK, we can measure, in terms of the distance travelled via the road network, how far that place is from the boundary of its nearest coalfield. So that gives us an idea of kind of how far away somebody in the labour, and all this data can be merged onto the labour force survey, I should say. So all these coalfield definitions have been merged onto the LFS within the Secure Research Service. The distance of all these LSOAs, again, can be merged into the labour force survey and the SRS on the basis of a lookup table. So we can identify for anybody in the labour force survey, are they in a coalfield, yes or no, or how far away from the nearest coalfield are they? So that's what we do. So we can do some, like I say, some descriptive statistics where we can look at the union membership within a coalfield, and we can see it declining steadily. On the bottom line, it's union density, it's percentage of employees or union members. So in coalfields, it's 32%. Outside of coalfields altogether, it's 24%. You can see it declining gradually there within kilometres of leaving the coalfields. So we're no longer talking about, comparing north of England with the southeast of England, with Wales and Scotland. We can now look at how union membership varies by kilometres as you move away from the boundary of these coalfields. So yeah, you see that declining pattern there. But of course, there could be many compositional effects going on there in terms of the existing industrial structure, occupation structure that remains within these coalfield areas. So we're going to estimate a very simple logistic regression from the labour force survey, which kind of takes account of the occupations, industries, and the personal characteristics of people living in these coalfields and beyond these coalfields, to demonstrate how the probability of union membership varies, compares for those inside coalfields compared to outside, and how it varies with geographical space. So what we see here, so overall, if you are living in a coalfield, comparing for other influences, they have an odds ratio of 1.24 of being a union member. So whatever, 24% more likely of being a union member compared to those living elsewhere. That's after taking account of, like I say, your job characteristics, workplace characteristics, and personal characteristics. We can then replace that and estimate a separate model which looks at distance from a coalfield. So our reference category is 100 kilometres plus, just for presentational purposes. So we see that compared to those who reside more than 100 kilometres away from a coalfield, if you are within a coalfield, you have an odds ratio of 1.47. If you move just 0 to 5 kilometres, so you move away from a coalfield boundary by just a mile or so, your odds of union membership declines from 1.47 to 1.31. So as you move away from the boundary of an industry that disappeared 30 years ago, within the contemporary period, you have a significant reduction in your likelihood of being a union member today, which I think is quite a fascinating thing. The idea that being a union membership is so closely tied to a place is pretty phenomenal, and decays very sharply as you move away from those places quite quickly. Obviously, the rate of decay declines as distance increases. So that's our multivariate estimates. We also produce regional specific estimates of this coalfield effect, and it works in most areas. So the reference here is the reference category is Southern England, 20 kilometres away from a coalfield. So I said in Southern England there were two coalfields, Kent and Gloucestershire. So this bottom chart there is demonstrating that as you move away, that people still residing in the area of the Kent coalfield and the Gloucestershire coalfield have higher rates of, are more likely to be union members than those who reside further away. And most parts of the UK had a coalfield, so we can do this on a regional basis. But you will see there, some areas it does break down. Strathclyde, it doesn't work very well. That green ribbon at the back there, and also the orange ribbon, the northeast. Well, coal mining is clearly an important factor in terms of predicting trade union membership, but it's not the only game in town. It's not always easy to measure the coalfield effect. So on the left-hand side, our coalfields that are in the northeast of England, those hatched areas, the Durham coalfield and the Northumberland coalfield, and they are important places. They remain conduits for trade union membership. But there are other influences in that part of the world. The Redcar steelworks are outside the coalfield, just to the south of the Durham coalfield there. South Teesside, with all of its manufacturing, its chemical plants, these are all also highly unionised places, and they have levels of union membership there that are just as high as those that existed within the coalfields in those areas. Those, I should say, those plants are often related to the coalfields. Many of the workers who originally were miners moved to those plants, and they brought with them their kind of attitudes towards industrial relations. So there's a relationship between the two. Some of those plants are also owned by the coal miners, the coal owners who were in the Durham coalfield. So there are relationships, but it's not, it wasn't the only game in town. Likewise with Strathclyde, we have the hatched areas there for the coalfields across the central belt of Scotland. A couple of things going on there. By the 1980s, the coalfield, 100 years ago, the coalfield of central Scotland would have been completely that central belt. In that part of the world, when the coal mines closed down, the coalfield shrunk. In Wales, the coalfield kind of remained the same shape, it just kind of hollowed out, but it remained the same size. In Scotland, it kind of reduced to these smaller areas. So I'm sure there are coal mining areas that are being missed by our definition of coalfields. We also have Red Clydeside, which is obviously the Glasgow area, the shipbuilding history there. There were other sources of trade union activism. Red Clydeside in the 1910s, 1930s, had the Singer strikes, the Singer sewing machine factory, rent strikes, anti-war movements. It's always been a hotbed of trade union activity. So yes, union membership in Ayrshire, Clydesdale is high, but it's not any higher than it is in Strathclyde due to the other influences on trade union membership that were in that area. So conclusions. Well, sub-regional data is essential for understanding trade union membership. That's the main take-home message. If you really want to understand who joins a trade union, you need far more detailed data than standard statistical regions, government office regions. Union membership spills over from the past. It spills over into different sectors. It spills over geographically beyond the boundaries of coalfield, but it does decay quickly with distance. A technicality, not particularly interesting in terms of coal mining, but the legislation that supports secure access to microdata isn't helpful in terms of maintaining these kind of websites. Projects have to be kind of time specific, have a specific outputs to them. I want to just kind of continuing to update union maps over time and adding more data to it, and gradually it becomes richer. That doesn't really work with ONS in terms of providing access to your data. They like to see things being done, completed, and then moved on. So it's going to be mothballed for a short time, and we'll come back to new maps in a year or so to update it again. Okay, thank you very much for your attention. Thank you.
Questions, please. Lars.
Have you looked at either internal migration or migration into the country and how that affects union membership? So if someone moves into one of these regions, are they more likely to join the union or not?
We have looked at migration with the British Household Panel Survey. We looked at migration. Now, is it in the blood or is it in the water, essentially? When people move to a high density area, do they assimilate to local area levels of joining behaviour? And we found that, we found that when the children of unionised parents move from Wales and the north of England to London and the southeast, they do retain their increased likelihood of being a member of a trade union. If their parents weren't members of unions, then they have very low levels of joining behaviour. Not only were they not members themselves, but they are migrators, and therefore they're probably not the kind of people who might be drawn towards being a member of a trade union. Likewise, when people from a less frequent migration direction, when people move out of London, the southeast, up to the north or towards Wales, if their parents are members of unions and they have that background in them, they tend to join if the unions are available for them to join.
Please. Thank you so much for the presentation. I have two questions. So one, do you control for the public sector presence in the
Yes.
So then the second question, how representative is LFS? I mean, at the such a local level, when you do like cross-sectional in 1 year, do you think it's like asking because I'm thinking about doing this myself. So like, do you have enough power to do this thing, or?
Well, yes, I
the data?
I didn't put the sample sizes up there, did I? When merging across 20 years like this, most of these local authority districts, they have thousands of observations in them. A couple of the smaller areas, and I'm talking about the peripheral areas of Scotland, we do get down to Western Isles, for example, just a couple of hundred. So in those parts of the world, the sample sizes are smaller. But with 20 years worth of data, in a majority of cases, you're talking about 1,000+ observation for each local authority district.
And then you show results for like different years separately, right? So then you do like a how do you do this?
Well, that was in the most, obviously we've been adding to the data gradually over time, over the years. And we got to the point last year where we thought, well, we actually had enough data for all these local authority districts to split the sample in half. I would never produce annual estimates. So quite simply, we had 22 years worth of data, and we thought, oh, right, we got enough here to look at the first 11 years versus the second 11 years. And that's what, so yeah, that's an example of how we'd like the thing to just keep on continuing, because gradually things become possible. But that, like I say, doesn't fit into the SRS view of what a project should be, unfortunately.
Please.
So it looks like you have a big sample size, but is it representative of the overall place that you're looking at? In other words, is there an issue of sample selection bias?
Well, we certainly are using the sample weights provided to us in the LFS by ONS, so the data is being weighted. So we turn the weights on. There are issues in terms of, for example, in some areas, telephone interviews are more likely to be conducted in rural areas than face-to-face interviews. So this might lead to a problem, for example, in Scotland, because there are response, not just in terms of proxy response effects in the labour force survey, but the trade union membership question is vulnerable to whether people respond to it over the telephone or face-to-face. Social desirability bias is having effect. So there is that effect. So I have to be a bit cautious there. But generally speaking, the weights are applied, and we feel that these are representative of their local areas.
Please.
Yeah, thank you for that. So I guess historically, the relationship between union density and political preference would have been quite strong.
Mm.
Interestingly, with the Copeland example you gave, is that just much weaker today, generally speaking, across the UK, or is that relationship completely broken down?
I think it might have broken down for a short time during the last election. I think people often say the thing is with voting is easy. You can decide on the day what you want to do. You go into a group and you tick something. Joining a union requires a bit more admin. You have to fill in some forms. You have to set up some kind of payment system. So it's not so easy to kind of flip in and out of union membership as it is to flip in and out of voting. So I certainly think with in the last election, and obviously lots of the Labour seats were lost in particular areas due to the various issues. The relationship got weaker. It might get re-established next time round. Like I say, yeah, voting is easy. You can change your mind easily on your way to a voting booth. Trade union membership is something which is a bit more sticky.
Thank you.
Please. Oh, sorry.
Sorry, it's just a very quick one. In terms of when you were looking at the labour force survey, you're obviously looking at a residence-based labour employment, and then you mentioned the sort of discrepancy with the annual survey of earnings, which I would assume is a workplace-based measure. Do you have any sort of considerations of the differences between residence-based, workplace-based measures of employment, and therefore the sort of impact on trade union membership?
Well, within the app, they do have location of residence as well. So sorry, yes, all of these statistics were produced on a residence basis. The ash as well was also on a residence basis. People become what they are by living in places, we feel. And we feel that it's more important, you know, what we're talking about here, intergenerational transmission, the importance of family, friends, locality, and encouraging union joining behaviour. Yes, in South Wales, most people in the valleys will now work in Cardiff, but their attitudes towards union membership has certainly developed within the context of the coalfield area in the South Wales Valleys. So it's our, you know, theoretically, we are interested in where people are living rather than the location of the workplace.
And so I was really interested to thank Helen Simpson on the effect of high-speed rail on local economies. Helen, please.
Thank you. So what I'm going to talk about today is a whole set of work that I've tried to do using mostly Office for National Statistics secure data to try and provide a sort of holistic descriptive picture of what happens to individual households and to businesses when we dramatically increase their connectivity to London. Not all of this will end up in the paper, but I've put a lot of it in the presentation because what I wanted to discuss was, you know, how suitable is it to use ONS surveys for a purpose that's quite distinct from what they were actually intended for, to actually look at the location of individuals there, where they choose to work, and also the performance of businesses at a small spatial scale. Click. Okay, so the sort of background, very broad background for this talk is and motivation for the work was really thinking about the effect of what are now called place-based policies, and are pretty, well, at least were pretty popular when the government was heavily focused on its levelling up agenda. I'm not sure it is still so heavily focused on it. So by place-based policy, I mean something that you typically think of like an enterprise zone, which is in operation within a very specific geographic boundary. So what we know from the literature on this, that if delivered at a suitable scale, this type of policy is likely to have some impact on, say, individuals living in what I'm going to call, or working in, the targeted location. So there will be an effect on the area within the geographic boundary which is targeted. But it is not necessarily the case that those people or businesses that benefit are those that were originally resident in this targeted location. So what a lot of theory and increasing amount of empirical evidence suggests is that these policies create spatial displacement, and that people, if they think they can get a better job in area X, will move from area Y to area X. Those in-migrants will get the benefits in terms of potentially a better job and a higher wage. If there's housing supply constraints, what will happen is that house prices and rents will go up, and some of the original residents whom the policy was put in place to benefit, they don't benefit from the higher wages. All they see is an increase in their housing costs, and they don't necessarily benefit. So I would like to try and look at this and get a sort of holistic picture of what happens in the context of a place-based policy. And we've seen discussion in the papers today about will HS2 go ahead all the way to Manchester. Quite often these large-scale transport investments are treated as a place-based policy with the objective of linking, well, not in the case of Manchester, but in some cases, a relatively lagging economic area into a relatively booming economic area. So I would like to think about who benefits from these improvements in connectivity. So first of all, is there any evidence that what I'm going to call prior residents, so people who are already living in these places, are able to gain in terms of labour market access better jobs? Is there evidence that the benefits of transport improvement are essentially capitalised into house prices? So there you might think about prior home owners as being the main beneficiaries. And also I wanted, when I started this project, to try and look at how businesses themselves are affected by being made closer to, in this case, it's going to be the capital, London. In terms of, we normally think about things like agglomeration benefits, market access benefits, but it's not necessarily the case that if you bring a relatively peripheral place closer to a relatively booming place, that the benefits will go to the peripheral place as opposed to the booming location in London. So I wanted to have a look at that. I'm not sure the data, that's the bit I'm more doubtful about whether the data are really up to it. Okay, so this is what I'm going to look at. This is from 2009, before High-Speed Rail 1, domestic high-speed rail service from East Kent, was opened in 2010. So I won't try and strongly argue that this is in some sense an exogenous shock to this area, but you could argue this because it's based upon the speeding up of the Eurostar line from London to Paris and Brussels. So I think this was sped up in stages. The Eurostar was sped up in about 2003 from the tunnel up to somewhere in North Kent. Then in, I think, 2007, it was brought into St Pancras as opposed to going into Waterloo. And then in 2010, what happened was some of these locations here were able to access the high-speed rail track, and this dramatically reduced commuting time into London. So Canterbury here goes from 102 minutes to 61, Ashford International 83 minutes to 37. So quite a big shock to commuting time into London. So as I said, what I'm interested in are sort of household location choices, house prices, labour market outcomes for prior residents, and I wanted originally to try and look a little bit about what happens to the business sector with its workplace stuff. So what am I going to try and use to do this? So first of all, some data that I'll show you in a minute, which we bought on rush hour commuting times at the postcode level into Bank Tube in the city of London. Roughly what you get if you went on Google Maps and asked for directions, and it says walk for 5 minutes, get on the bus, get on the train, walk for 5 minutes. So this will have one period, it's very noisy as you'll see in a minute, one period pre High-Speed Rail 1 period immediately after High-Speed Rail 1. For house prices, we're going to have postcode level data from the land registry on housing transactions where we get some additional characteristics of the property sold. We're working on this for so long, I can now update it for 2021. Some census data for an immediate snapshot of what happened to the population in these areas. At the output areas are slightly larger, 40+ households. We're going to try and use a survey that Rhys just referred to, the annual survey of hours and earnings, which is designed to look at hours and earnings, but you observe in it the full postcode of the workplace and full postcode of the place of residence. So try and look at residential and workplace reallocation as a result of this. And then I was, I'll show you at the end, trying to use the business structure database. So that's the population of, what ONS believes, population of plants in, I'll just say England because that's what I'm using, across all sectors of the economy. So we should know the population, we know the post, well, we used to know the postcode, we used to know the full postcode, it's now been replaced by the postcode district. So the first chunk of the postcode, so we're in WC1A, I think. That, and then the bit where it's much more tricky, to use the annual business survey to actually try and look at measures of productivity. At the end of the talk, I'll explain why this is difficult, and that's due to aggregation of reporting. Paul said that business surveys were weird. This one, you can report on your activities at a level that is more aggregated than an individual plant. And obviously, if you were Tesco's or someone, you could in principle report on all Tesco stores together at once. So it's incredibly difficult then to know what's happening at a small spatial scale. Okay, so this is the data on travel times, where essentially this red line is the Eurostar line, and green here, which you won't be able to read, gets to about a 50 to 60 minute reduction in travel time from this location into a bank tube station. So most of the analysis that I'm going to be showing you is going to be focusing on Kent. Really interested in Kent. In some cases, I do use a wider commuter zone, like a full donut around central London, to try and think about, is there something different happening in Kent as a result of this big shock to the rest of the commuter zone? You'll see some horrible red patches here. Tried to investigate why travel times were going up so much and whether it was just a blip on the day that they did this. On average, travel time reduces about 14 minutes or 10% in Kent. On average, around the rest of London, it's basically zero. It averages out to nothing. But let's focus on Kent. I'm going to summarise what I find for households, and then I'm going to try and show you some pieces of evidence that support what I'm saying here. So we definitely see population movement towards areas, so postcodes within Kent, that are brought closer to London in travel time, conditional on geographic proximity to London. I cannot tell you whether that is purely reshuffling within Kent, which could, depending on how you want to interpret the magnitude of my estimate, but I'm just observing people leaving and moving somewhere else, or whether it's people, there definitely are some people moving from central London, and instead of choosing to go and locate in Hertfordshire, somewhere else, moving to Kent. Movement there, as you would expect, in this country, accompanied by an increase in house prices. So some initial evidence on sorting. I then can move to the annual survey of hours and earnings to try and say something a little bit more about the nature of this sorting. We're going to try and show you that people who either already work in London or who start working in London move in order to have a shorter commute. So there is movement among this population who are already working in London, who you might think benefit from this, or who start working in London, or people who stop working in London move in the opposite direction because they don't value the reduction in time. So there is sorting among people who work in London, as you would expect. I can also show you some evidence that people who have shorter commutes to London do other things, which you might expect from the literature. They earn more. They also work longer hours, and they're also more likely to change workplace because they have access to this, better access to labour market. So this is all. This is about the characteristics of people. Can I say anything about the characteristics of people who live in places that are brought closer to London? It's very difficult to find evidence that those people who are already living in these locations are more likely to start working in London as a result of this travel time shock. And given that, it's also very difficult to show that they start earning any more. So less evidence that the prior residents in these places are getting better access to the labour market. So I'll first talk a little bit about the land registry data and the census data. Everything that I'm going to show you is super simple. I'm going to be regressing some outcome at an area level. Let's say it's a postcode and it's a house price. I'm going to be regressing that in a time period T on the time it takes to get from that postcode to Bank Tube Station in period T. And I'm going to be putting in a postcode or area fixed effect. So try and identify it from a within area change in the commuting time. Also going to control for some just geographic proximity to London. So not the time, but the just distance. Dummy variable. That's it. I'm just interested in what this beta coefficient is telling me. I'm going to mostly estimate on the sample for Kent that's outside the green belt of London to try and just not capture this London effect. And in some cases, I'll expand it out to the rest of this commuter ring. Okay, so what do I find? We take the whole of Kent. These coefficients are negative, which means that if you experience, so commute is measured in tens of minutes, if you experience a 10-minute reduction in your commute in an area, it looks like house prices are increasing by about just over 1.5%. If I take these more peripheral areas, this is areas which were 10 kilometres away from Ashford, essentially, so the ones right on the edge, it gets much larger. You can do this in different ways. If you really focus on the boundary of Kent, it goes up to about 3.5%. So house price increases, and interestingly, in this case, house price increases that we don't really observe in the rest, if we include the rest of this commuter ring. There is something happening in Kent as a result of this in terms of demand for housing, which is not observed in the rest of the commuter zone. Can also use the census at this output area level to look at what happens to population. So we observe here a 10-minute reduction in commute is associated with a 4.4% increase in population, age 16 to 74. I have no idea why I chose 16 to 74 as opposed to 16 to 74, but it is. Because it actually overlaps with this category. So there's an increase in population in these postcodes, the output areas, and again, it could just be reshuffling within Kent. The share of retired people, both in Kent and in the wider commuter zone, goes down. These individuals move away from these areas. They no longer value to the same extent this access to the London labour market. So some evidence of population movement in the census. We also, in the census, you can look at the industry and the occupation that people report. So we see a big decrease in transport, communication, construction. I suspect these are people building the high-speed rail line. We see increases in the people who report working in wholesale and retail, business services, and hotels and restaurants. So we don't know in the census necessarily where they work. Could be that they're now working in this now booming area of Kent. Could be that they're all commuting into London in order to do these jobs. You can also look at other things like qualifications. And when we look at that, we find actually it's people who have what I would call level 3 qualifications. So age 18 qualifications is their highest qualification. That's the population segment that it looks like is moving into Kent. The share of the population with low or no qualifications decreases. So perhaps an indication that some sections of the population are being priced out of these areas, that perhaps the policy was intended in the first place to assist. Okay, moving on to the annual survey of hours and earnings. So this is a 1% sample of the employed workforce on the basis of a couple of letters in their national insurance number. As far as I know, it has nothing geographic in its sampling, and it's just purely done on the national insurance number. So is it appropriate to use it to look at movements and reallocations in response to this? I don't know how a national insurance number is allocated, completely randomly, I assume, and that the letters, so let's take the random sample of the working employed population. Just to remind you, because I'm going to show you something with distance to London on it in a second, these areas in Kent that were heavily affected, they're about 80 kilometres plus from London in terms of geographic distance. First thing I'm going to look at is pre and post HS1. Where do people in the annual survey of hours and earnings who move place of residence move to within Kent, and what does that distribution look like? Well, the red line is post HS1 and the blue line is pre HS1. Post HS1, it looks like we've got a bit of an increase at these shorter distances, and then from about this point out after 80 kilometres, we've also got an increase here. This is all movers. I also looked at where do movers who work in London choose to locate pre and post HS1, and here for this section of employees, now we see a fall at these smaller distances and some evidence that they do tend to be locating now at greater geographic distances from London, which is exactly these areas which saw the biggest decreases in travel time. So I think some evidence of sorting here among people who work in London, they're now wanting to locate at these more peripheral parts of Kent. Last thing I'm going to show you is, let's get this right, of the people who work in London at each of these distances, what fraction of them are, I call them in migrants, movers in. And you can see that the orangey red line is pre-HS1, the bluey grey line is post-HS1, post-HS1. A huge fraction of the people who work in London at 80 kilometres plus are people who've moved into that location. Okay, so then I wanted to know, does the decrease in travel time affect labour market outcomes for prior residents as opposed to these movers? I'm not going to show you all this here, but just in purely descriptive terms, just describing the cross-section for both prior residents and movers, we can show what we'd expect people who are closer to London are more likely to work there. They're also more likely to change workplace, they work longer hours and they earn more. This is, I think it's interesting to document this pattern, but it's not particularly new. Less evidence that HS1 brought about change in prior residents. As I've already argued, it looks to be driven by sorting. What I'm going to show you is two things. First of all, estimate something very simple, the outcomes on a sample of people who are ever resident in Kent at some point during this 10-year period. Both people who never move, they stay in the same place, and a set of people who move. And for the set of people, it's essentially the same model as before. So there's an outcome, which I'm going to regress on their commuting time. And in this case, as well as having an area or postcode fixed effect, I can also include an individual effect. So for people who never move, the individual effect is essentially going to be the same as a postcode effect. Whereas for people who move endogenously closer to London, even when I include the individual effect, I'm still going to have variation in their travelling times. So I'm going to use something about how the results differ when I use these two different fixed effects to try and say something about sorting. I'll then back that up by showing you estimates just on a sample of people who never move. Okay, so there are two outcome variables here, the probability of working in London and log annual earnings. Here, when I include no person fixed effects, no postcode fixed effects, no geographic distance indicators, a 10-minute decrease in commuting time is associated with around 3.8 percentage points more likely working in London, and the baseline is about 15%. Once you include person fixed effects, falls a bit, but it's still statistically significant. And remember that for the stayers, this is like is identified of within area variation in their travel time. For the movers, they can be endogenous and everything. This goes down a lot when we just control for geographic location, because obviously that's strongly correlated with travel time. Once we include postcode fixed effects and enforce the fact that we only use within postcode variation in travel time to identify the effect, it goes down a bit further and the standard error increases. Same pattern for earnings. I mean, here the coefficient is the same, but what I'm arguing is that a lot of this that we're observing here and here is just people either having historically sorted into these locations or sorting in response to the travel time. You can also just look at people who don't move. You just look at people who don't move. You don't need a person fixed effect and a postcode fixed effect. You see that they've sorted, but when we try and identify the impact just from a shock to the travel time for that individual, given where they're living, we don't really find anything on their propensity to work in London or an increase in earnings. Okay, businesses. How are businesses? I'll whiz through it, Martin. How are businesses affected by being better connected? So I've already said a lot of this. We might think there are benefits. We might think there are benefits from market access. We might think there are benefits from changes in input prices for these or costs. So could be agglomeration benefits, benefits from market access. Could be that these businesses are now brought into competition with businesses in London. So previously people in Kent worked in Kent, they went out and ate in Kent, they shopped in Kent. If they are now working in London, and this is pre-pandemic, so they are now consuming in London as well as working in London. So it could be that for some sectors, they're now in competition with alternative businesses in London. There's population increases in Kent. So there could be an increase in labour supply, but if these new population are all working in London, that doesn't necessarily mean that labour is now cheaper in Kent. It could be that land prices are also going up in the commercial sector as well as the residential sector. What might we potentially expect from this? Potentially being brought closer to London could lead to the exit of the least productive businesses. I'm not going to be able to show you any evidence for this. Could lead to productivity growth among survivors. I'm not going to be able to show you any evidence of this, which is why I found the business sector section of this paper a little disappointing. What I can definitely show you again is I can show you exit, but I can't show you that it's the least productive businesses that are exiting. And I can show you sorting. And I can show you geographic sorting on the outcome variables that we're interested in exactly the way you would expect. So more productive businesses, businesses that pay higher wages, larger businesses are all closer to London in travel time. Try to use business structure database, which is population of plants. Relatively straightforward. It's population. You can look at entry, exit, size. I'm not sure entirely how often the employment data are updated in that in terms of size, but you know something. This is where it got more tricky. So the establishment survey, if you really want to know what's happening at a very small spatial scale, you've got a problem that plants don't report at the plant level. They can report at a more aggregated level. It could be from their headquarters in London, reporting on a whole selection of activity across the country. What do? Ignore it, use it anyway, impute it down to the individual plants, but what do you impute this on? Employment. If you impute it on employment, you're essentially assuming that labour productivity is the same in all of these plants. Is that actually, so I haven't done that. You could, which I have tried doing, only focus on single plant entities. We know that's correct. Highly non-representative sample of plants. Plus, it certainly used to be the case, and Rhys can tell me if I'm wrong, that ONS would sort of sample one of these and then sort of almost guarantee that they wouldn't sample them again for another 5 years. So absolutely nightmarish in terms of looking at changes over time. In principle, though, and I had a go at it, you can aggregate down to some area level, if you wish, and you could estimate at either the establishment or plant level. I've already said that, so I can show you these patterns that lower commuting times are associated with higher employment, productivity, etc. I see a little bit on terms of entry and exit, which is interesting for these businesses, which again could be the ones that are more in competition with businesses in London. I see much lower entry rates and higher exit rates as a result of this reduction in commuting time. So potentially some sorting for these sectors that are brought into competition for London. One nice thing you can do with the business structure database, you can't observe relocation. I would love to be able to observe relocation. You can map the structure of a firm. So you could, and I tried, look at how the firm restructures itself when it has multiple plants. And actually, if you do that, you do see a similar pattern in that these big firms in these sectors are less likely to put new plants in these affected areas in Kent, and more likely to open them elsewhere. Right, I think I've run out of time, and Martin will tell me. So I can show you this. Okay, are there questions?
Well, maybe if you could carry on.
Okay. So, yeah. Okay, so what can I show you? From the business structure database, you can either aggregate the data to some sort of, I aggregated it to an area industry level, area industry year level, to try and account for compositional changes in activity in these areas. This was, I think, when you could still get postcode sector. You can't anymore. So basically, all of these negative coefficients, whether you look at the area level or the plant level, are telling you that plants have higher employment the closer they are in London, closer they are to London in travel time. I tried to take this sample of plants and take surviving plants and look at before after changes for them. I lost so much of the sample that I'm not even going to put it on the slide. I don't know whether it was wrong, or the amount of churn in the business structure database is so large that the average plant only lasts a couple of years. It seemed implausible, the loss of sample. What I can tell you is, when I try and do that, the coefficient becomes insignificant. There's just not enough. There's not enough there to say that I can pick up any effect on plants that were already there in terms of an increase in their size as measured by employment. You can also see reductions in entrance for some of these sectors that I was highlighting, wholesale and retail business services, and an increase in exit for these sectors. So potentially some effects are being brought into competition with London. Okay, so what I really wanted to do was try and say something about productivity and being brought closer to London. I mean, a lot of the discussion around things like HS2 is that the benefits will go to Birmingham, or the benefits will accrue to the locations that are connected in, or some of the, I don't know where it's been connected, Stoke-on-Trent, or somewhere that's been connected into Birmingham, Nottingham. Can we see productivity gains for plants that are brought closer? And again, I really struggled to show this using these data. Again, you can show these cross-sectional relationships. So being closer to London is definitely associated with higher measures of plant performance, value added, labour productivity and wages. And these are some of the magnitude of these estimates in terms of almost the spatial sorting of these plants across geographic and time space. But it's very difficult to identify anything, again, looking at within plant changes as a result of reduced travel time. this is data aggregated to the area level. So here, interestingly, there's not really, I had kept splitting out Kent from the rest of the commuter zone, but actually there's no real reason to do so in this data. We're just seeing a geographic pattern of firm performance, which is essentially roughly the same across these two areas in terms of distance to London. So whatever measure you want to choose, value added, data productivity, or average wages, we're seeing that these are higher the closer you are to London. This is at an area level. Once I try and put in an area fixed effect, the coefficients reduce or become positive and become essentially statistically significant. So even for Kent, where we did actually experience a big shock, I find it very difficult to find anything. I will confess to you, I cannot remember, because I've not kept, I've ditched this bit of the paper, how exactly I aggregated this data to the area level. Knowing myself, I probably just thought, okay, that establishment is reporting on the multiple plants, but I'm just going to treat it as it's all there. And I'm not going to start apportioning it out everywhere, because that's just going to smooth everything out and I'm going to lose everything. So I think it's interesting to document this sort of spatial gradient in plant performance measures, but I can't find you any concrete evidence that high-speed rail 1 transformed what's happening in Kent in terms of the original plants that were there. It may be that the in-movers are more productive, but it was not transformation. Okay, so conclusions then. I think I've got reasonably convincing evidence of spatial reallocation of households either within Kent or the wider London commuter belt in response to lower commuting times, but less evidence of labour market gains for original residents. What does this suggest? Well, potentially we need to think a little bit more closely about the distributional impacts of these major transport investments and who actually benefits from them. With significant in-migration, what you're potentially seeing is benefits just accruing to existing landowners, and potentially, if rents are increasing as well, lower income households actually being displaced from these areas and moved to even more peripheral, less well-connected locations. And then I've said that, so I will shut up because I'm over time.
Thank you. Well, are there any questions that people have? Not. Please, at the back.
So did you look at, was there any changes in the commute price?
Yes, so I've worked out what it was. So obviously price matters as well. So you can go back and you can go to an online Kent newspaper and you can compare the price of you can buy when you travel on one of these trains, either a sort of chugging speed ticket or a high speed ticket, and the premium that you would pay in 2010 to save an hour of travel time, so say half an hour into London, half an hour back, is about £6 in 2010, which was about the minimum wage at that point for an hour. So my view is it was not that expensive. Other people have told me who are more who live in this area that there are other benefits of this train. It's like more reliable, it's much nicer to work on. So obviously it's not just the travel time that matters, but I don't think the price was prohibitively expensive. And we also did an exercise where we tried to work out, you know, in terms of the amount extra that you're paying for your house on top of the additional travel cost. It was about £7.50 an hour or something like that. So it wasn't massively expensive, I would argue.
Yeah, I just got an interesting thought experiment. If you just compensate people for, in different places, like differently, by different amount, that sort of, equates the saving, like commute time. Whether after that, I think after that, you get a clearer sort of estimate of the impact of commuting time. You can start with it.
I mean, ultimately, I think we saw, yeah, I mean, we tried to sort of put a present value valuation on the house price gain, which I can't remember now, but we did try and sort of place a value on it just by looking at the house price, because we couldn't see anything for the residents in terms of getting higher wages. There's another. Yeah.
Okay, so another question.
I was just going to ask whether you can do anything about the location in London where you work. Presumably this train takes you to King's Cross, in which case you benefit a lot from your work.
I do.
Victoria, I mean.
In that, so for some people, they were made worse off because they used to go into water.
Yeah.
So the answer is in the Ash, definitely I can. And also I could, the way I have the travel time data, I could just then work out, instead of going from King's Cross, I could work out literally going to where you were. Not sure I've got strength to do that, but I could. Yes. What would be nice, and now you've said it, I think would be to look at, of those people who moved to Kent, are they working in places that are around King's Cross? Because clearly if you work, I came to Paddington today, you don't want to, yeah, so I think that's nice. That would be more doable, to look at literally where they're employed. Those specific movers, you can do that in the Ash, as long as you don't report anything disclosed.
Okay, well, thank you very much indeed.
So this is work with Jonathan Halket, who's at Texas A&M, and Mateusz Mysliwski is in Bergen, and yeah, this is work in progress. It's the first two slides I'm going to promise you a lot, and then I'm going to tell you that a lot of it's not complete. So please excuse me for that. It's very close related to some of the work Helen was doing using some of the same data sets. So in urban economics and trade, there's a long tradition of using logit-based models to analyze spatial sorting. So where do people choose to work and where they choose to live? There's a paper by Anas from 1981, and then you can see the sequence of papers going up to most recently here I'm citing 2015. There's some further work after that I'm not citing here. What we're going to do, we are going to use several data sources to estimate a sorting model of this urban economics tradition. We're going to use land registry, the energy performance certificate database, because not only do we want location of the property people live in, we want the size, and for the size is not measured in land registry, but it is measured in the EPC database. We're going to use ASH as well. ASH we're going to use in a very similar way to Helen to look at where do people choose to work and live. We're going to look at their earnings, occupation, industry. We're also interested in businesses. How big is the business establishment? How much space are they using? And what are they paying for rent? For that, we're going to use the Valuation Office Agency database. The model that I'm going to show you towards the end is the model people choose where to live and where to work. That choice is going to balance different locations at different house prices. Where you work, pay different wages. And then there's a cost of commuting. Cost of commuting depends on travel time. We measure travel time using Google Maps. I'll show you how we do that. And it also costs money. And we're going to use TfL data just to estimate travel costs, monetary travel costs. A few other data sources I'll use along the way as well. The model, so in this literature, a lot of the models, there's a homogeneous set of workers. All workers are the same. You don't distinguish between different types of workers. We think that's a big limitation, and so one of the things we're trying to do here is allow for heterogeneous workers. I'm going to show you today a baseline version of the model where there's two types, so it's not that much heterogeneity. Two types of workers, but actually, well, I should take that back. There's 3 industries in the baseline model. We could have more, but there's 3 industries, 2 types of workers, so there's actually 6 types of workers. I'll come back to that when I show you the model. What are the questions we want to use this model to try to address? Here's where I'm going to promise a lot but have no answers yet. How important are agglomeration economies for local productivity? What I mean by agglomeration economies, if you put all of the finance workers in the City of London, are they more productive there because they're all together in the City of London? Or if you spread them out, would they be equally productive? So in terms of thinking about urban design, urban spatial analysis, agglomeration economies are a key factor, because if there are agglomeration economies, it's a benefit to put people together. We want to know how much of the variation in wages is due to some locations might have some intrinsic productivity factor, or it might be that there is agglomeration, or it simply is that different locations have different workers with different skills. Is it due to different choices of industries to locate in different locations? There's another reason why wages and productivity might vary across locations, because of compensating differentials. So in the equilibrium model I'm going to show you, workers choose to live and work in different locations. What is going to balance supply and demand are going to be two prices: the price of housing and the price of labor supply. So in the hedonic equilibrium urban economics literature, depending on the balance of supply and demand, some of the benefits of being in a particular location could be capitalized in house prices, and some can be capitalized into wages. How much is going to depend on the balance of supply and demand. So that's what we want to answer. How are those differentials capitalized into prices? Thinking about workplace amenities and residential amenities. People, when they choose a location to live, they care about how long does it take to get to work, but they also care about, are there nice parks in the neighborhood? Are there nice schools? Are there other nice amenities of the neighborhood? Or are there disamenities? Is there air pollution, noise pollution, etc.? On the business side, or also a different question is, in this equilibrium model, how does the supply of housing affect the outcome? If you increase the supply of housing in location X, how does that spill through the economy? Or the supply of office space? You convert some property from office to housing or vice versa, what's the impact? How important is public versus or subsidized housing? So in our model, public housing will be a set of housing in a location where people pay subsidized rents. They're typically going to be low-income people. They're not going to play a role in the housing market because they have housing provided by the government, but they will play a role in the labor market because they work. And when we think about what do you want to use this model for, is you want to try to evaluate what is the social welfare impact if you change the government policy or change the economic environment. Obviously, the welfare includes people living in private housing and public housing, and it also includes the profits of the businesses. So the goal of this project is to try to address these questions using MSOA level data with multiple worker and industry types. That's what we're attempting to do in this paper. We haven't finished addressing these questions. And some of the questions that Helen was addressing, well, if you have dynamics, because you change an investment, how does the model change over time? And we're not going to say anything about that at all in this project. We're going to use a lot of different data sets. We use several different models. We're first going to estimate several elements of the model using semi-parametric statistical methods. So we're going to estimate a model of house prices as a function of size, location, and other housing characteristics. Commercial rent as a function of the same set of types of characteristics. Semi-parametric model of wages as a function of unobserved worker type and of location. Commuting choices, and for each of these estimation tasks, we'll use different data. So for the house prices, we use land registry. Wages, we use ASH. Travel time, we use Google Maps, etc. We also have demand for space. So these data sets here don't tell you the size of the property. Well, the EDC database does, but doesn't tell you who's living there. And for that, we're going to use in a very limited way, we're going to use the English Housing Survey, which has a very comprehensive data set of information about people and the dwellings they live in. So that's roughly the statistical part of what we're doing. And then we have an equilibrium economic model. Again, people choose where to live and where to work. There is a supply and demand for labor, housing, and commercial office space in every location. Wages and house prices adjust to balance supply and demand. That's the model. And the output of a firm in this model, there is an externality, which is the output of the firm depends on the workforce, depends on some exogenous local productivity, and it depends on agglomeration economies, which we have a model of, which I'll show you later. We set up this model with the data here, the parameter in this model can be estimated using a generalized method of moments estimation method. So that's the method we're using. Now I'm going to go through. Don't have a lot of time. We're attempting to do a lot here. We've done a lot of the data work. We haven't yet finalized estimation of the model. I want to give you a brief overview of some of the data work and some of the statistical models for each of the different variables that we're studying. So starting with house prices and commercial rents. So house prices, as I said, a function of location. We're going to measure location with geographic coordinates. We have data at the postcode level. So we're going to take we've modeled this as a function of latitude and longitude, but also transforming latitude and longitude into polar coordinates centered on Trafalgar Square. And so we have a non-parametric model of how do house prices vary with location. It's also non-parametric in how do they vary with dwelling size. I'll show you some of the results of that model. We do link lands registry and EPC data. We completely ignore linking error, and there's a lot of linking error. That's something we need to improve upon. We use a very similar model for office rent. The data in the office rent database is not the same as in the house price data set. In the office rent, in the VOA data, you observe the rent, you observe the size, and you observe the industry. You don't observe a lot else about the commercial property. The key feature of the model is that prices of housing, rents for commercial office space or other types of commercial space, and wages, they vary across locations, again, to equate supply and demand, and they compensate in part for travel costs and in part for residential amenities. So some places are more attractive to live than others. Workplace amenities or disamenities, some places are more attractive to work. Okay. What is the semi-parametric model we use? So the overall project is quite complex. We use a relatively simple semi-parametric model of the value of a property. Here is equation 1. We have time fixed effects. So we're using data from 2008 to 2000. In this version of the project, or the results 2008 to 2016 or 17. And there's the time fixed effects that I'll show you. There's some interesting changes over time. There's the size of the house and other characteristics, which I've listed here as a single vector h. And then I have the non-parametric function, which is a function of geographic coordinates x and y. Do I need to tell you anything else about this? That's all I'm going to tell you about that. Here's an example for the East. We actually estimated this model for all of England, and we did it separately for 11 regions. Here's an example of just a cross-section. How do prices vary with longitude in the East Midlands? And you can see it's not linear and there's a complex pattern. There's some areas where it's very precisely estimated, and there's some where it's not precisely estimated. Here are the fixed effects in our model. This shows you roughly the evolution of average log prices from 2008 to 2016. Here's London, which started at roughly, what, £350,000 and increased to more than £600,000. The second highest is is the Southeast, which is £250,000. Everything else is below £200,000. So there's regional inequality shown quite extreme levels, and you can see the huge increase in regional inequality over that 8-year period. So if you were to go back in 2018, clearly you should sell housing here, buy here, go up here, and then you can sell it and you can buy here. But if you live here and you want to move to London here, you can't do it. Unless you live in a very small house. Here's price versus size for 4 regions. This is total floor. Sorry, the labels are very small. This is floor area measured in square meters, ranging from 50 to 250. This is This is price. This is price. And the shape is the same for every region, but the levels are quite different. You can see London, 50 square meters ranges from about 20, it goes up to more than 1,500. That doesn't sound right. I think this might not be London. Sounds too small, perhaps. Here is this is maybe easier to read. This is price per square meter. In the center of London, price per square meter is more than 15,000. It drops to about, as you get, so this is not, so I said this, the center, this is for all of London. The price per square meter for small flats is close to 15,000. For larger properties, which this is controlling for location, for larger properties it drops to close to 5,000 or 8,000, sorry. And then it's pretty level. For the other regions, you can see same shape roughly, but they're much lower levels. So here it's 4,000, here it's 4,000, here it's 3,000. So again, you see the big differences in prices across regions, and you see there's a very strong nonlinear relationship between price and size. The smallest properties are very expensive per square meter. It's very flat for the larger properties. Same picture for commercial properties, and here you see for small commercial properties, there's a very high premium per square meter. And then for larger commercial properties, there's a flat relationship between size and price. And that's true for all the regions. But again, the levels for London are very different from the rest of it. And these are for small properties, commercial properties up to 300 square meters. This is for big ones larger than 500 square meters. And for large ones, the relationship is flat. Here's a heat map of prices versus location. And you can see London, there's a big peak in the center, and then it spreads out. As you move away from the center, prices go down. In the Northwest, there's two peaks. I should know the definition of peaks, but I don't remember. And East Midlands and West Midlands, there's peaks here and here, and then it declines in other areas. So you can see the relationship between price and location is very complex, and it varies across regions depending on many economic factors. So that's our model of prices and rent. Now let's talk about wages. We're going to estimate wages as a function of location, and unobserved. ASH does have information on workers. You know their occupation, their age, but there's a lot of, you don't, for example, know their education or qualifications. So you don't know their experience either. So we're going to model worker types as being unobserved. We're going to use a mixed model to model this. And what else are we going to do? What else? Want to sample business establishments. Here's the model. So we have worker I in sector S in time period T. Yeah, in year T. Log wages follow this mixture model. Capital H, or H indexes a type. So there's capital H types in the application. Currently, capital H is 2. So either type 1 or type 2. And with probability pi, worker I is type 1 or type 2. The probability of being each type depends on some worker observable characteristics. The ones we use are age, sex, part-time status, and occupation. And then conditional on being a type, we have a log linear model for wages, which there's an intercept, and then there's a component of wages that depend on location. And this part of the model is semi-parametric. We're going to model B here as a vector of interactions between polynomials and Fourier series. So it's polynomial in distance from the center of London, Fourier series measuring the angular distance from due east. So that's the model of wages.
Does the agglomeration just come through the geography?
So this is wage. I'll show you the agglomeration when I get to the model now. So this is simply in the model, the model is going to predict a wage for each type in each location. That's what this is. And I'll show you, then we're going to use this wage data to estimate how much of it. We're going to use this model along with some other data to estimate the agglomeration economies. But I have to come to the model before I tell you how that works. Once we estimated this model, we then can, for each worker, we can infer what's the probability that worker is type 1 versus type 2. And so we estimate the probability that each worker is type 1 versus type 2. Do I need to say anything here? I'll skip over that because there's not a lot of time. Here are some of the results. There's 3 industries and 2 worker types. Industry 1 is roughly government, public sector. Industry 2 is retail, and industry 3 is everything else. This was initial categorization of industries. We're reworking this because clearly, if you're studying London, you need to treat finance separately, and we haven't done that right here. So currently, finance, I guess, is in industry 3. So interesting things, public sector. So most of the sectors, wages decline with distance from the center. They're highest in the center, and they're lower further out. And then given each distance, there's variation in wages, which vary across, depending which direction you go from the center. Industry 1 and Industry 2, there's less dispersion conditional on distance. Industry 3 is much more heterogeneous conditional on distance. Here are some heat maps of wages as a function of location, again for the 6 types. Industry 1, wages are highest in the center, and they decline, as you can see from these pictures. Industry 3 is that heterogeneity is reflected. There's 2 peaks here. Well, 3 peaks, really. 1 in the center, and then these 2 other ones. We haven't investigated that further to understand better the results, but those are the results for the wages as a function of location. So what do we need for our model? We're going to need prices of housing. We're going to need rents for commercial office space. We're going to need wages as a function of location. We also need the predicted commuting. There are data sets where you observe, for example, the census, you observe in every location what fraction of workers commute to every other location. But we need not only the number of workers, but the workers of each type, the probability of commuting from each MSOA to every other possible MSOA. And from our estimation, we have for each worker the probability that they are type 1 versus type 2. And so we can construct a kernel density estimator of the probability that a type H worker commutes from home or residential location X, Y, subscript H to workplace destination X, Y, subscript W. So this is our predictor, this is our kernel estimator of the probability that a worker of type H commutes from one location to another. Going back to the small area discussion this morning, the assumption here, which allows us to get estimates even for areas where we don't have a large sample, is that these variables, the pi, the x, and the x's, are continuously distributed across locations. And so therefore a non-parametric estimation method is valid. And we can also construct the mean estimate and also valid confidence intervals for that estimate. Travel time and cost. For travel time, there's 2 parts to the model. One, for every pair of locations, we predict the probability of commuting by automobile, by public transport, and bus/tube and by rail. We do that from the National Travel Survey. That part's not done yet, actually, but and then Then we know the price for each of those modes of transport. And then travel time, what we do is we download a sample of 5,000 random pairs of origins and destinations. And with each of them, we measure the travel time according to Google by public transport and private transport. We did this pre-COVID. And then we estimate a non-parametric regression of travel time or log travel time on these origin and destination coordinates. So that's our model of travel time. So now we have wages, house prices, rents. We have travel times and travel costs. The model that I'm going to write down and describe is going to assume that every location has a residential amenity that people care about, that affects their utility from living there, and a workplace amenity that they care about that affects the utility or disutility from working in a location. Workplace amenities also affect productivity. We're going to assume that every location, the amenities in part depend on observable features of the location, such as parks, schools, green space, etc. Part is going to be unobservable. That's going to be the unobservable that we're trying to account for in our model to estimate things. One final thing, we use the English Housing Survey to estimate how, on average or at the median, how big a property do people with different incomes live in. Okay. So here's the model. The household chooses dwelling size and where to live and work. And the trade-offs are they like bigger houses because it's a consumption good. Different locations have different residential amenities. Different workplaces have different workplace amenities. They get income from work. They don't like to work, but they get income from work. And there's a disutility for commuting because it takes time and it costs money. So that's going to affect, that's how the household choice problem is structured. Firms don't choose location. Every location, there are some firms. What firms do is they choose how much space to use and how many workers to hire of each type. Every location is endowed with a baseline productivity. It's simply exogenous, it's fixed in history or by the government or some other mechanism. And then in the equilibrium, after they hire some workers, those workers create output. And because the model allows for agglomeration economies, that the equilibrium productivity is not the same as the baseline productivity. It's the baseline productivity plus the potential benefit from agglomeration. Okay, it's still work in progress. I showed you some notation above for wages, house prices, etc. The model notation is going to be slightly different, so I apologize for that. It didn't fix that problem. But here's the model. There's a fixed number of locations. You could think of this as an MSOA. There's a fixed number of workplace locations. The workplace locations might be bigger. They don't have to be the same as the residential locations. And the household chooses a residential workplace location. There's people with different skills. At the moment, we have two types. And some of these people live in private housing. It's a static model, so even though the data are based on owner-occupiers, we're going to convert those prices to equivalent rents as if every year they rent their property from themselves. So there's private household residents, and there's a council house resident. Those populations are fixed. Static model. Income, there's potentially a lump sum tax or transfer from the government. There's a benefit schedule, G. So W is the wage you earn if you are, let's see, if you live, let's see, J, I have to remind myself notation. S is the skill. J is the K is the location and J is the industry. So that's the wage you get from that industry location skill combination. You work 1 unit of time minus the time required to travel from I to J. So that's your income. And then F is the monetary cost of travel. So that's the income of a household. Utility then, a consumer or a household or a worker, those are equivalent in the model. They're going to choose where to live and where to work. 5 minutes, great. Okay. And they're going to get utility from consumption and housing, which depends on their income and the house price. They're going to get utility from residential amenities. And they're going to get utility from workplace amenities. There's a logistics shock, which also affects utility, which is added on at the end. Anything else? The model for the amenities are given here. They depend in part on observable characteristics of the location and in part on an unobserved epsilon. Similarly for the workplace amenities. Statistical assumptions, this is going to be a type 1 extreme value distributed random variable. Epsilon here, these are distributed, continuously distributed, statistically independent of Z. This is the utility you get from consuming goods and housing. If you take the derivatives of that, that gives you the demand for quantity of housing. And that's the model for demand for housing. Social housing is assigned, those people are assigned residential locations. They pay a subsidized house price, PRC, and they also choose where to work. They don't choose where to live, they only choose where to work. So aggregate housing demand in a location I, it's the total population multiplied by the probability that person is living in that location, summed across all workplace locations, summed across all types and industries. So it's number of people, probability of living location, demand for housing. That's the total demand for housing in location I. Total supply of labor in location J is the total number of people, the probability of living in I and working in J. This is the labor supply of the private residence. This is the labor supply of the council housing residence. That's the total labor supply times 1 minus the time spent commuting. So that's labor supply. Firms. So this starts to get at Peter's question. There's case sectors. Here's some data from 2015 from the GLA. These are the most important sectors in London. Finance sector is big, retail is big, and the government sector or public sector are big. We're going to lump the other ones together. And in fact, government sector is slightly different because their hiring decisions might be slightly different. Production function, where's the agglomeration economies come in? This is our assumption about the production function for industry K in location J. It depends on the total number of workers working at the firm, summed across skill types. Depends on this productivity parameter phi. Theta K here, and rho K is the elasticity of substitution across different types of workers. This is the quantity of space employed by the firm. And then what's the productivity parameter here? It depends on the number of high skill versus low skill workers. It depends, okay. It depends on the sum of workers of different skill types. So I was promised you I'd show you agglomeration economies, but there's an additional term here, which is it not only does it depend on the workers that you employ yourself, but it depends on the other workers employed in the same location. But that term is missing from this equation. So if that term is missing, there's no agglomeration economies. If it's present, it suggests that if there's more high-skilled workers at a firm near you, that may increase your productivity. And that's the, does that effect exist or not, and how important is it? It's something we want to estimate. From that production function, we have derived an inverse demand for labor. This is the demand for labor from industry K and location J. Inverse demand for space. And you put those together and you get a set of conditions that describe an equilibrium. You have supply and demand in every location. Supply and demand of what? You have workers, office space and residential space, prices, wages, price of commercial space, price of residential space. So we can, given everything I've described to you, we can compute those equilibrium prices and quantities and compute an equilibrium in this economy. Here's the equations for one particular location. You don't need to study them. It's 3 demand equations, 3 supply equations, and they can be solved. How are we going to estimate this model? I'm going to skip through this because there's only not much time left, and there's just a bunch of equations. The equations we estimate end up looking like this. We have these unobserved errors that affect the amenities in each location and the productivity in each location. Those are going to be equal 0, and they're going to be uncorrelated with the exogenous variables in the model. The exogenous variables in the model are observable characteristics by assumption. These are assumptions. Exogenous characteristics of the location, the supply of office space and residential space, and that's all. So that's how we've written the code to estimate the model. We've estimated on some simulated data. We haven't completed the estimation for the data for London. That's where we are in terms of estimating these models. I'll just conclude. So rich data, meaning data from multiple sources that with a lot of detail of both individuals and locations on small area outcomes, can be combined to create a very rich description of house prices, rents, wages, commuting patterns, demand for housing. If you take this data, combine it with a model, you can then produce an estimation method that can estimate how productivity and other key parameters vary across locations. And once you've done that, once you've estimated this model, then you can start to ask and answer a lot of, I think, very interesting questions about if the economic environment changes because there's migration or out-migration, changes in commuting technology, working at home technology, how does that affect local economic outcomes? Prices, wages, welfare, etc. Or if there's a big place-based policy that builds a new cross-rail or high-speed rail, how does that affect conditions? That's the goal of using this model. Thank you very much.
Thank you very much. We have time for a couple of questions. Well, could I ask a question, please? You mentioned working from home.
Yes.
I mean, is that a simple change or is it a complete structural change in the model? Because working from home changes the computing and calculus very considerably.
So it's a big change in the technology, and we need to think through carefully. We have to think through how it changes the production technology. Yes. So I think once we make a decision about that, I think it doesn't change computation models. I don't think it would change that aspect of the model, but thinking through carefully how it affects the technology is important.
Thank you. Please, at the back.
Thanks, Lars. I have a quick question about how, if you had any sense of how the whether the floor area actually is the big driving factor on pricing, because, you know, in London, also, there are certain, well, as a measure, particularly London, there are certain blocks of development where a 4-bedroom house is a different size in Waltham Forest as it might be in South Kensington, or, you know, whatever. Similarly, 3-bedroom stuff, and the pricing is often not dependent on floor area, but more how many bedrooms there are, and that kind of stuff. So, I spotted in a couple of those graphs, you know, there was a bit of a wiggle in the noise and stuff, and I wonder if that might be related. In fact, you know, if you're buying a house and you know the area you want to live in, the floor area is almost a secondary consideration. It's the number of bedrooms it may have. So that's the first thing. And then the second thing related to EPC data is the stuff that we've looked at. I mean, it's quite noisy because the surveyor is just, depending on how diligent the surveyor is, you know, and even neighbouring properties in an identical terrace may have quite different values in terms of age and floor area and the rest of it. So just wondering whether you kind of detected any of those things in the way you've been looking at it.
So in the floor area versus bedrooms, in this project, we haven't mentioned much, but previously we did some work with the English Housing Survey, and it didn't make hardly any difference at all. You can model things in bedrooms, or you can model things in floor area, or both. For owner-occupied housing, you can include both. For rental properties, including both didn't work because conditional on bedrooms, there was 0 variation in the floor area. So yeah, I think that distinction for this analysis from that previous work appears to not matter very much, but a different distinction is clearly other characteristics of quality of the house are missing from this analysis, and those are important. So if those quality characteristics are correlated with location, which they might be, this analysis of the price of location will be biased. So unobserved quality property is important. Age of property, insulation, energy efficiency, other things. Energy efficiency we observe, it doesn't matter so much, but unobserved quality is important. The other is for detached housing, the lot size. So we don't observe the lot size. And in London, that matters less, but for outside of London, that matters a lot. And that's clearly correlated with location.
Thank you very much, Roy. For the final question. Yeah. Thanks, Lars. So there are a lot of moving parts in your model, and it's a challenge to see how they all go together. But I focused on one bit, which is probably terrible. Going to anyone. So you had in your commuting cost bit 1 minus the time spent commuting. And that looked weird to me, because if you're doing a job, you do the whole job and then you spend some time commuting. So why isn't it 1 plus the time commuting?
So I think in terms, that distinction doesn't matter very much, because if you, whether you make it model the way we did or the way you suggested, the parameter estimate you get will be slightly different, but as long as you don't change the technology, as long as the technology is the same for everyone, and you don't change it in the middle of your analysis, it's not going to affect things. But if it does vary across people, then it could matter. So if some people are working 8-hour days and other people are working 12-hour days, it's going to matter. Yeah. But if different people have different ways they trade off time and time commuting work and money, then it's going to be very important.